Number two, you should be able to look at this and say, oh, I know that's a parabola. And you should be able to do that because it has a y squared, but it doesn't have an x squared. So what that means is that I'm going to dump the x terms over to the right-hand side. I'm also going to do the same with the 17. I'm going to complete the square with the y's, and then kind of resort things and get it into my regular form for graphing so that I can identify the focus and all that stuff. So the first thing I do is rewrite y squared minus 6y, and I guess I'll leave a gap to complete the square on, equals, and then I get a negative 8x minus 17. So, gotta complete the square on the 6y. So, what do I add? I need to do it to both sides. I do a plus 9. So I gotta go and do a plus 9 to this side too. Factor, I get y minus 3 squared. So y squared parabola, I know it's going to open sideways, equals negative 8x minus, comes out to be 8. So I can now factor out the right side and write this as y minus 3 squared equals negative 8 times x plus 1. So there's a couple things that I can take from this. First off, I know that my vertex has coordinates. The x coordinate comes from this. It's a minus 1. It's the opposite of this number. And the y coordinate is the opposite of that one. So, yup, it is 3. So my vertex is at minus 1 comma 3. My a value, remember, that number right there, that 8, that negative 8, is equal to our 4a. Divided by 4, I get a is equal to minus 2. And what that tells me is, which direction the focus and or how far the focus and the directrix and all that stuff are. So I'm going to go ahead and plot the vertex. Negative 1, positive 3 puts me up here. And now I know that it opens to the left, so I'm going to go ahead and go 2 units. Maybe I'll label that as V. If I had a little bit more space here, it'd be nice. You can be a little bit more accurate on your paper, hopefully. So I'm going to go 2 units to the right, or to the left, and that becomes my focus. So my focus is at negative 3 comma 3. I get the negative 3, 1 by looking, 2 I can subtract, or I can add this negative 2 with that negative 1 to get this guy. The last thing is to get the directrix, and that is just a dotted line like this in the opposite direction of the focus. There's this thing called the Latus Rectum that we've talked about in some classes. That tells me that I go up. And this is not something that is necessary on the test, but it can't hurt to show it. I know that, just real quickly, so the parabola is going to go like this. And I know that, remember the whole equidistant thing, the parabola, the points on the parabola are equidistant from the directrix and the focus. So this little spot right here is important because anywhere on this line that I'm kind of drawing, this vertical line, is exactly 4 units from the directrix, no matter where I am on that line. So you notice that, well, my a value is 2, right? Negative 2, whatever. So I got 2 units here and 2 units here. That's 4. So I can go up 4 and down 4 and get 2 dots that are, so that distance is 4, this distance is 4. It fits our definition. This is 4, that's 4. So I can basically figure out the spread of the parabola by looking at by using that 4. Now, the latus rectum is this length right here, which is always, because of the nature of how this equation works, going to be this 8. So if this was a 12, then that would be 12 units, because I would have 6 and 6, and I would have 3 and 3 to match up with that. Anyway, that last part's not necessarily necessary. You do need to have the focus, the vertex, and I guess I should write out my directrix is x equal to +1.